Today's presenters are Ariana Driftall and Paul Wacker. Ariana is our Product Marketing Manager for the Industrial Wireless Group here at Moxa, and Paul is our Product Marketing Manager for the Edge Connectivity Group here as well. And with that, I will go ahead and turn it over to Ariana to get things started.
Thank you, Kelly, and hello, everyone. And I'd like to second my welcome, and thanks for joining us today. As Kelly mentioned, my name is Ariana Driftall, and I'm one of the product marketing managers here at Moxa. We're excited to present to you guys some really cool topics today. Our agenda for this webinar is going to be an introduction into the 802.11 standards and the security associated with them, the different types of wireless topologies you may want to consider when deploying wireless within your facility, some of the best practices that we recommend for the installation of wireless. And then for the second half, we're going to focus on how do we get specific devices onto a Wi-Fi network. So we'll cover Ethernet to Wi-Fi, serial to Wi-Fi, and then finally I/O to Wi-Fi. Now, wireless has come a long way in the last, 5 to 10 years. When we first started having wireless transmissions, we were at a pretty slow transmission speed, whether this be from a cellular side or from a Wi-Fi side. As we've moved through and some of these technologies have started to, bring forth faster data rates and some better improvements, we find that there's actually still a lot of customers who perhaps don't even need the speeds, especially those who are trying to do something like a serial or an I/O to wireless. A lot of times some of the older kind of tried and true technologies can still be used very successfully with those types of wireless implementations. Nowadays, today, there are basically 4 to 5 main protocols, depending on how you look at it. 802.11b is the oldest one that's still commonly in use today. It operates on 2.4 gigahertz and has a maximum rated data rate of about 11 megabits per second. So this is the slowest of all the currently used protocols. But this one, as I mentioned in the previous slide, can still be a very relevant protocol to use, especially for those who are trying to do low bandwidth applications such as serial to Wi-Fi. 802.11a and 802.11g are the other two kind of legacy standards that are still pretty widely used today. They both have a max data rate of about 54 megabits per second, so they are suitable for serial-based to Wi-Fi, I/O-based to Wi-Fi, and low bandwidth Ethernet to Wi-Fi, meaning no real video. They're still in use today, and virtually all devices on the market support one of those two protocols. The newer one that is the most widely used today, which is 802.11n, also operates on both 2.4 and 5 gigahertz. And the nice thing about 802.11n is that it has a much higher data rate than some of the older standards. So depending on how many radios and how many MIMO antennas you're using, there are systems that can get upwards of about 600 megabits per second, which is suitable for even multi-camera or multi-video streaming across a wireless network. Kind of here, but yet on the horizon at the same time, is 802.11ac. And 802.11ac is a protocol that's starting to get a little bit more widely used for consumer markets and enterprise markets, but has been very slow to adopt in the industrial market. So 802.11ac is, kind of considered to be the true gigabit wireless, and has speeds depending on, what type of settings you have of up to about 7 gigabits per second. So very, very fast standard. But again, not quite as widely adopted in the industrial market as it has been within the consumer or the enterprise market. Now, the most important thing to keep in mind, or one of the most important things to keep in mind when implementing a wireless network, is to make sure that you have security. We live in a day and age where, unfortunately, people try to, steal or grab data whenever they can, especially data that they're not authorized to see. And so it's very, very important to secure your wireless network. And this really is relevant at your home or your offices, as well as your industrial type applications. You just don't want anybody being able to get into your network that you don't want on there. So there are 4 real types of security standards. The first is WEP. It was a very, very old standard. It was the original one. And nowadays it can be cracked in a matter of seconds if you have someone who knows what they're doing. So we don't typically recommend using WEP security unless that's the only thing that you have support for. WPA was a successor to WEP and is a much stronger encryption method. And following up with that was WPA2. And WPA2 is really considered to be kind of the standard that most people use nowadays. If you want to take that one step further, you can go to 802.1x, which is basically a WPA or WPA2 enabled security along with a Radius server or certificate-based encryption, or excuse me, authentication. 802.1x is the highest level of security. So if you have an application where you are very, very security conscious or you cannot risk anybody hopping onto your network, 802.1x is the way that you're going to want to go in terms of authentication. Now, it's also important to note the types of topologies that exist within Wi-Fi before you end up putting some of your devices onto the Wi-Fi network. The first and the most common is what we call our point-to-multipoint or AP client topology. This is probably, I would say, 85% of all applications that we see are going to use this type of topology. It's the same one that you likely use in your homes, in your offices. It's when you have one main access point that's serving multiple clients throughout a facility. The AP, you can have multiple APs or access points scattered throughout your facility and even more clients, but this is basically also known as an infrastructure type of topology. The other one that is used is called master-slave or point-to-point topology. So this is a topology where you're essentially bridging two separate locations. So for example, if you have a remote, let's say, water or wastewater facility, and you want to connect that back to a control center, you can have one device on the master side and one device on the slave side, connect them in a point-to-point location, and allow the devices that are connected on the slave side to basically pass through the master and be able to, be monitored from that central control room. So this is the type of topology you use when you want to have a dedicated one-to-one link and you don't want to risk anybody else being able to get onto that network. Now, master-slave can also be used for point-to-point, as I mentioned, but it can also be used when you have a dual radio access point as almost kind of a repeater mode. So that's going to be the example that you see down at the bottom. So you can essentially take one single radio product, you can connect it to a dual radio product, which then essentially passes through that signal and then passes it out again to another slave device. So this is really good for those of you who have applications that are maybe farther than traditional Wi-Fi can allow. You can use these types of devices to basically bridge that connection or repeat that connection onward and extend that point-to-point connection that way. Now, the other that's possible, and this is probably the least commonly used amongst all of them, is point-to-multipoint using something like WDS, which stands for Wireless Distribution Signal. So this is kind of like a very basic type mesh. WDS has been around for many years, but it's a proprietary technology for every vendor that implements it. So unfortunately, with WDS, you can't combine two vendors in a WDS network and have them talk to each other because the implementation is, as I mentioned, proprietary. That's why more people are moving to more of a mesh type topology, because you have that extra flexibility. But WDS basically allows you to link multiple devices, and it allows you to then, communicate directly to each other because WDS uses the MAC address of the radios to actually form communication links. So it's great because it is very reliable once it's up and running. Because it's MAC address based, you don't have unauthorized devices hopping onto it. But one of the biggest downsides, aside from the proprietary nature of it, is the fact that for every node you add, you basically cut your throughput in half. So you can see that the throughput that you get through a WDS network will go down really rapidly as you add more and more nodes to it. You also have the ability to do wireless redundancy. So this is a topology that can be used with specific vendors, and what it does is it basically creates a hardware redundancy. So you would have a redundant access point and a redundant client, and the redundant access point would broadcast at two different frequencies. So you'd have one radio, for example, broadcasting at 2.4 gigahertz, and the other radio broadcasting at 5 gigahertz, and the redundant client would be receiving both of those signals at the same time. That way, if you have interference across one, for example, 2.4, because that one tends to be a little bit more susceptible to that kind of interference, and the 5 gigahertz link tends to stay active, and then you will still be able to get your data through to where you need to go. This, again, does require some specialized hardware, so you have to have a vendor that supports it, but is a very good choice for when you have mission-critical or more mission-critical data that you need to ensure gets to its final destination. All right, so it's time for our first poll here, and I think Kelly's going to light it up here for you guys. And the question is, have you implemented a Wi-Fi network within your facility? And if so, what type of topology do you use? So the possible answers here are, I haven't implemented wireless, I use AP client or infrastructure mode. I use point-to-point, or I'm not quite sure what topology I'm using. So we'll give you guys just a few seconds to bring that in. And it looks like AP client is in the lead, and actually a fair number of you look like you haven't implemented wireless yet at your facility. So that's certainly, perfect timing for you guys to be on this webinar. Hopefully we'll be able to educate you on how to do that. And looks like we'll give it just another second or two. All right. So thanks everybody for voting. Here are the results of that vote. So it looks like 29% of you say I haven't implemented wireless. So again, hopefully we'll give you some good data to use if you're thinking of doing so. 53% of you use AP client, which is the most common type of topology. 11% of you, use point-to-point, and the last 7 of you aren't quite sure what topology you're using. So thanks guys for participating in that. We will be having a couple more web poll questions here throughout the webinar for you as well. All right, so now that we've discussed the types of topology and the types of protocols, we're going to move on to some of the best practices for wireless deployment. So there are 4 kind of stages, if you will, when you want to deploy a wireless network. The first is what's called a site survey. The second is the actual network planning. The third is the installation, and the fourth is kind of the test phase to make sure that everything is working properly. So the first thing that you have to do when you're deploying a wireless network is conduct a site survey. So the purpose of a site survey is really to figure out where the best place for your wireless installation is going to be and how far that wireless installation will reach. So in other words, if you have a facility that has multiple rooms, you'll be able to determine using site survey software basically how far into these rooms an AP will reach. And you'll be able to determine if you need multiple APs to cover whatever given area you need to have. These are really, really useful, especially if you're implementing a wireless network from scratch, because it eliminates a lot of the guesswork as to where it is that you want to be able to put any of your wireless devices. Now, there's another thing to keep in mind, and that is a lot of physical things, if you will, can affect a wireless signal. So I included a chart here to kind of show you the amount of loss that you can kind of assume you're going to get with specific materials. So obviously an open space is going to give you 100% of an effective signal, meaning you're not going to lose any of your signal. But there's pretty much every other type of material that you can think of is going to cause some sort of loss, whether it be minor or significant to the wireless network. So you can see that even a window, you would think, hey, it's clear, should be easy for the wireless network to pass through, will lose you about 30% of your effective signal. So these are things that you want to look at when considering, deploying your network. And again, those site survey tools will help you because it'll actually be able to sense for you if your wireless network will be able to penetrate any of these materials. So the next thing that you want to keep in mind when doing wireless is the planning phase. So once you've figured out, okay, I know I need 5 APs, for example, to cover my given location, you have to figure out, okay, well, what type of topology do I want to use? Am I trying to bridge 2 separate locations? Am I trying to bring multiple client devices onto my wireless network? And knowing those things will kind of help you to determine what type of topology you're going to want to use. The other thing in the planning is to determine your throughput that you need. So you'll have to figure out, based on the type of clients you want to connect, how much bandwidth you're actually going to need. If you are going to be something like a serial device and putting it onto the Wi-Fi, we all know that serial tends to be a slower communication protocol, so you likely won't need anything super fast to be able to bring those types of devices to your wireless network. However, if you're trying to do something like video over wireless, and particularly if you have multiple videos that you're trying to stream over the wireless, it becomes very critical to know the amount of throughput that each one is going to require in order to stream properly. So if you have one video feed, typically the older AVG protocols are going to be okay. If you're trying to do any more than that, typically we'll recommend using 802.11n or AC to make sure that you have enough throughput for all of your video streams. The other thing that you're going to want to keep in mind is the type of antenna that you use. So there are basically two most common types, an omnidirectional and a panel antenna. An omnidirectional is what looks like basically just a pole, and it radiates its pattern in 360 degrees. So if you look at the radiation pattern, it looks pretty much like a donut. So it kind of goes outward, and the higher the gain of that omnidirectional antenna, the flatter that donut then becomes. The other type is a panel, which basically looks like a square or a rectangle that's flat, and it basically broadcasts only in one direction. The omnidirectional antennas tend to be a lot more common in an AP client or an infrastructure type topology, and panel or directional antennas tend to be more popular for point-to-point type topology. So the next phase is the installation phase, and this is one that can be, a little bit more complicated for those who aren't familiar with a wireless installation. When you're trying to do wireless, obviously you want to have the best type of the best line of sight that you possibly can, and that means making sure that your range of your wireless network is free of obstructions. So if you have obstructions and you need to get around them, typically you'll have to either raise the antenna or move it to a different location that will help avoid those things. But the other thing to keep in mind is if you are installing wireless in an outdoor environment, and obviously in the industrial space we do see quite a few of those, there are some additional hardware pieces that you would want to consider when putting your wireless network into place. In particular, having something like a lightning arrestor in areas that are very prone to lightning, like the South. You also, it's a best practice to install something called a DC block, which basically stops any kind of ESD in the air from coming into the antenna port of a wireless network. And then also having something like a DC to DC power isolator to protect the power input of your radio is also a very good best practice. Now, once you've site surveyed and planned and installed your network, the final thing is to make sure that it's working properly. There are many tweaks that typically need to be made to wireless networks, and the one thing that we say to people who have never done wireless before is every installation is very different and very unique. So what works for one of your neighboring facilities may not perhaps work at your facility, or what works for you at home may not work for you in your industrial space. Wireless is meant to be kind of fine-tuned, and so there are specific tests that you can run to make sure that your wireless network is functioning as you want. And again, a lot of times they do require a little bit of fine-tuning to make sure that you're getting the optimal performance out of those networks. All right, so time for our next poll here, and the question is, have you implemented a Wi-Fi? Oh, I'm sorry. Have you had issues with your wireless network, and if so, do you know what the cause of those issues were? So the answers are no issues. I had problems with interference of potentially other devices or other non-wireless devices. Some of you, looks like you had no good line of sight. And it looks like none of you don't know what your issues were. So that's always, I guess very few of you weren't sure what your issues were. So we always like to see that. Obviously, we don't want to leave any wireless issues unsolved. As I mentioned, they can take a little bit of fine-tuning, but more often than not, in fact, in most cases, you will be able to get some sort of a resolution to figure out why your wireless network is potentially not working as you need it to. So we'll give you guys just a couple more seconds. It looks like most of you have gotten your votes in, and there's a pretty good mix, actually, of what you guys are seeing. All right, so here are the answers, or here are what you guys have responded to. Looks like 31% of you have had no issues with your wireless network, which is awesome. 38% of you had issues with interference. 29% of you had no good line of sight or line of sight issues. And 3% of you, unfortunately, don't know because their issues were never solved. So thank you guys again for participating in that one. And I believe we'll have one more here in just a little bit for you guys. So we talked a little bit about the basics of Wi-Fi and some of the best practices when deploying a wireless network. So now we're going to tell you how you actually get wired devices onto a wireless network. So we're going to start with the one that's probably the simplest, and that is Ethernet to Wi-Fi. So the biggest thing to keep in mind when doing an Ethernet to Wi-Fi device is whether or not you need NAT, or network address translation. So NAT is needed pretty much any time you're going to have more than one device behind a wireless client. Meaning, if you have a wireless client and you have a PLC and maybe an old serial device server, those types of things, you're going to need your device to support NAT so that it knows what device behind the client was specifically requesting or sending data. Now, sometimes you'll need a router to go along with this. Some wireless devices will have NATing support for them, but there are basically three types of NAT that you'll see. One is called one-to-one NAT, the other is called end-to-one NAT, and then the last one is called port forwarding NAT. Now, one-to-one NAT tends to be the most common, especially when you're doing a point-to-multipoint topology. The reason for that is that most wireless devices that are acting as clients are only going to have one device behind them. But typically, if you have one-to-one NAT, you don't need to have a full NAT functionality in your wireless device. It'll just automatically bridge that connection through. Now, if you do have multiple devices behind a wireless client, for example, if you have 3 or 4 devices that are connecting maybe through a switch, you're going to need to have NAT support either from the wireless client side or from a specific router side. So if you have what's called an end-to-one need, the initial connection comes from the LAN side. And then if you have port forwarding, your initial connection comes from the WAN side, meaning from a remote network. So the port forwarding would basically be like a polling. So if you have a remote user that's trying to poll data that's on the wireless network, that would be what we would consider basically a port forwarding NAT situation. All right, so we're going to have another poll here for you guys, and after that I'm going to turn it over to Paul. So the question is, what are your challenges in connecting I/O over Wi-Fi? And your responses are limited knowledge of wireless, integration of existing systems, coordination with IT, information security, or all of the above. So we'll give you guys just a few moments here to answer that. And once you guys are able to get that answered, then we'll go ahead and turn it over to Paul, and he's going to lead you through getting both your serial and your I/O devices onto a wireless network. All right, so it looks like you guys are, there's a couple that are in the lead here. We'll give you guys just a few more seconds to do it. But it looks like about 10% of you have a limited knowledge of wireless, so hopefully we were able to help with that a little bit and get you guys some information on that. It looks like a decent amount of you are going to be having problems with integration with existing systems. 10% of you say coordination with IT, which of course is always a challenge. 15% of you say because of information security. And 36% of you say all of the above. So again, thanks for voting in our poll. And with that, I'm going to go ahead and turn it over to Paul. And he is, again, going to lead you to, how to get your I/O devices onto a wireless network. So Paul?
Ariana, thanks so much. Let me go ahead and turn it over here. Bear with me just a minute and we'll go ahead and switch over to my screen here. And there we go. Great. Great overview of Wi-Fi and some of the technologies. And certainly there's a lot there, and there's lots of great content that we produce. So if there's more you'd like to see, reach out to us after the webinar for the you'll have a chance to make comments. Let us know how we can help in terms of your projects and designs and what you're working on with that. So let's shift a little bit from the underlying technology of Wi-Fi and wireless and talk about doing some practical things with it. And certainly one of those things that's often misunderstood is being able to do more than just connect your handheld tablet or laptop, but able to do that Wi-Fi client type function to bring on Ethernet devices. But there's a whole lot more, and the integration to bring on other devices is so much easier than that. So how about serial devices? Well, we talk about serial, it's not what you had for breakfast. It's about connecting some of these legacy devices. And sometimes we kind of joke about this being a little legacy, but it's incredible how many products that are industrial products that are still shipping today that the only means of interface for configuration, setup, and monitoring is a serial port. And kind of categorically, I'll show you a couple of those, but there are are so many, it's incredible, that are still not Ethernet or Wi-Fi equipped. So we're talking about being able to exchange information with devices by being able to signal between those in a bidirectional fashion, utilizing just a couple of lines on that. The most common type of this is RS-232, right? So you might be working with these, whether it might be a older PLC or maybe an HMI that you might have, or a power meter, the ubiquitous DB9 ports out there, and there's a lot of devices that are still using this as a fundamental interface, right? Here's some of those devices. Some of you could probably have one or many of these in your applications, or perhaps applications that you're looking forward to work with, ranging from control devices to operator interface devices to maybe even a marquee display that's above your production floor for them. The interfaces range a couple different types, RS-232 being very ubiquitous. And with that, you might also find some other ones like RS-45 that have some special attributes for doing multi-drop and so forth. And in the past, you might have had to grab a laptop and run down to the plant floor, open up a panel and plug into it. We're going to talk about some ways to make your life easier. Things that were previously done for configuration setup, programming or download, monitoring and so forth, and a various number of needs like this, right? So I think this is just a refresher, and for some of you folks that don't have some of the experience with working with this equipment, some of the common uses for it. Now, one of the interesting things, there's a whole range of technology out there able to bridge a device that has a serial port to Ethernet and IP networks, a category we call a device server. Device server, a little bit like that ubiquitous print server that's in your office, lets you share a printer on your network. This is a technology that was developed to be able to connect those wireless devices to get on Ethernet and technologies like Wi-Fi. And it's kind of brilliant. The whole concept is being able to take that serial data and encapsulate it on a internet protocol datagram, or IP, if you will, and move that across the network. And one of the beauties of this is if you use internet protocol, you can move this over a wide variety of different types of networks, whether that's wired Ethernet or Wi-Fi or cellular, or just pick and choose what your underlying technology is to transport that, and you can do this really easily. So again, drop-in networking solution to do this type of thing with that ubiquitous type of technology we call a device server. You might hear some people refer to it as serial device server, or maybe the IT folks, if you work with some IT people have been using this for a long time to remotely monitor and manage their servers in the data center. They might call it a terminal server. Again, same technology for using that. So one of the technologies is being able to use this to extend your connections over Wi-Fi, and that's really easy to do, again, as a drop-in type of solution. Ariana talked about having that architecture with the Wi-Fi access point. So in this application, kind of taking a look here, you can see up in the right-hand corner your Wi-Fi access point over here. This might be used to connect multiple devices on your shop floor or in your environment over here. Even if there is no access to other systems on the network, the access point can make that wireless network work between these guys by deploying two individual devices. One of the simpler modes of setup is a pair mode connection, meaning that I can take and connect device A over here on the left with device B over on the right and be able to exchange data amongst those, just amongst the two devices. Real simplistic application, real common application as an easy way to be able to connect those wirelessly. Okay, great. So that's one of the applications. Again, easy to set this up in a matter of minutes to be able to connect those devices to be able to share data. Now, some of you might be saying, hey, I've got a SCADA application and my SCADA system needs to talk to these devices. How can I do that? Particularly if you might have existing installation and haven't upgraded to the latest versions. One of the ways you can do this is with utilizing that same devices in a slightly different configuration. In this application, let's say you've got a scale attached to some equipment that's on your shop floor, and you want that scale to talk Wi-Fi to some of your IT systems. One of the things you can do is take the same two components. We're going to use the access point over here to connect to our network. We're going to use one of those wireless device servers out here connected to your device. You know, pick it, whether it's RS-232, 422, or 485, and that's going to connect to your server or your PC-based application over here. And the magic here comes with a piece of software called a virtual COM port driver. That's a piece of software that gets installed onto your PC and allows that Ethernet attached asset out there over Wi-Fi to map into your application as a virtual COM port, right? So Ariana talked about these ubiquitous serial ports. This allows you in your software to address all of this infrastructure on Ethernet via Wi-Fi to a serial attached device to look like it's a local serial port right there on your local PC. Really great technology, great to use with these legacy applications that may not have the latest and greatest capabilities built in. And in your application, you're going to kind of select from your setup menu and map this in. And there's a little bit to do on this in terms of the setup. You'll say, in this case, COM10 on the PC maps into the IP address of this wireless device server out here, you know, on the right-hand side of the page. Again, just brilliant. Shows you how easy it is to plug and play this stuff together in a matter of a few minutes, have this up and running, and add new capabilities to your system and take advantage of the benefits of Wi-Fi technology. Okay, so let's take a look at maybe a common application. This is an application, you know, we see a lot of, and is interesting, you know, especially when you kind of take a little bit and think about why do you use Wi-Fi. Ariana talked a little bit about some of the common use cases, and I know a lot of us utilize Wi-Fi at home, perhaps, you know, on our tablet, doing things, you know, at home. Maybe you're using a tablet at work now, or have a mobile phone that jumps on your company's network, and things like this. And I think one of the things we forget to consider is the cost of infrastructure to support adding new devices. And here's an application we see that's pretty interesting. We've seen in recent years a lot of folks that want to be able to take fixed assets. In this example, we're talking about a CNC machine on a factory floor. There have been a lot of new phases of integration of this equipment. Let's say, for example, you want to get that CNC machine connected to your production office, and you want to blanket that with Wi-Fi. Easy to do. One or more access points throughout your facility. Then each machine gets one of these wireless device servers that get attached to the CNC machine. And that CNC machine, that serial port's now able to take advantage. So you can trickle feed a CNC part program in G-code down to your machine to do the tooling for that, right? This is just one of hundreds of examples. And you might say, well, gosh, why don't I just drop a Cat5 cable down to the machine? And the real benefit here is what's the cost in doing that? Got to have an electrician come in, put in conduit for that. We've got to pull cable for that, bring that to a switch. We've got to make sure that that Cat5 cabling is not more than a couple hundred feet, you know, for the capabilities of that. We might have to run media converters to do fiber to ROPS to the access point to do that, right? So the real value here is that cost savings. You know, put one AP in the ceiling, and within, you know, several hundred feet, you can put a number of machines. You know, generally 20 to 30 might be good practice for that. And the other part of this is easy to reconfigure systems. Maybe a little better in that example I talked about of having a scale. Oftentimes there are weighing processes and flexible conveyor lines that you might want to reconfigure periodically. Lots of real common examples on the factory floor for doing things like this. Good. So we'll talk about a couple application considerations, and you know, for today's purposes, we're trying to keep this real high level and give you guys some food for thought about new applications and usage of maybe some of your existing things here. So we talked categorically about being able to take advantage of your IP infrastructure and utilize wireless to add more devices and, you know, increase your productivity by bringing these into place. You know, a couple application considerations of what are you connecting? 232, 422, 485, right? You know, you might want to think about that. Oftentimes, a lot of the hardware that's commercially available out there in the marketplace is available to do all three protocols or all hardware connection types. How many ports are you connecting? Are you going to put one Wi-Fi device server next to each one of those assets? So one per scale, one per CNC machine. Or might you want to put multiple devices out there? One common thing in that application scenario with the CNC machine is we're finding that some of the integrators out there doing this also are deploying a barcode scanner to be able to do a job control. So you might need one serial port for the CNC machine, one serial port for a barcode scanner. You might want a two-port Wi-Fi device server for that. Access mode, how do you want to access that? Is this going to be just one device to device, or maybe one PC or server to multiple devices utilizing the virtual COM port? Talking about that application for the CNC application, which is generically known as Digital Numeric Controller, DNC, we find that PC device application with a virtual COM port is real common. If you're doing SCADA and you have a favorite SCADA software, and I can go off about half a dozen different types of packages for that. Most all of those packages utilizing your existing industrial drivers have some means of doing serial encapsulation, which is a checkbox on your setup for that, to enable redirecting that serial communications over a TCP IP connection to that, and it would use that. So think about the access mode to make sure that your serial device server supports that. And lastly, any special application needs, right? This is maybe the minor thing on here, but is this an application where you have devices that are moving around within your network environment? That is, they're not fixed. And might there be some things where there's network interruptions that might have other additional needs for data buffering? That is, if we're doing a logistics application for a warehouse and wanting to have barcode scanners capture information to go into a shipping and receiving application, is there some need for data buffering if there's a periodic interruption to the Wi-Fi network? Okay, kind of minor things, but just things to think about in what you're doing. So some basic things to think about in application considerations as you're looking to how to deploy this technology to solve some problems within your application. Great. So just a quick look at some of the serial types of things. Again, I hope that kind of helps stimulate your interest of some of the off-the-shelf commercial solutions that can quickly and easily connect these serial devices. And again, the serial devices can range thousands of different things. And again, don't forget there's a lot of not just existing products, but even new products that want to take advantage of the benefits of wireless, but you don't have that capability built into these products, and you can use that serial to Wi-Fi solution as a bridge to that. Let's push out a little further to the edge of the network and talk about some of these assets that may not be so smart and have a serial port, and we're talking about devices with I/O. Let's do a quick refresher on I/O as to what that is. I know in these webinars we tend to get folks with a pretty broad range of experience, maybe not necessarily control engineers that know how to design with PLCs and RTUs and that type of thing. So bear with me a minute. We'll talk a little bit of back to basics on I/O just to be able to kind of have a common understanding of some of these things. When we talk about I/O, we're talking about really touching those sensors and actuators that are inside of a system at the furthest reaches of a network, right? When we talk about this, we're pushing out to the network edge, and there are two fundamental categories for this with digital devices and analog devices. Digital are on, off. Is it running? Is it stopped? Is there alarm? Yes or alarm? No. Whereas analog is things like, what's the current temperature? What's the pressure? How high is that level within the tank? And we get kind of specific about some of these things. So categorically, those are our two different types of fundamental ways of characterizing I/O. Let's take a couple looks at those, right? When we talk about inputs, we're talking about things like a push button, okay? Push button that says, is this system running or stopped? Input might be, is there a proximity sensor? Is there a product in place to do a machining process or not? Again, on-off status. We might also have different types of smart sensors here at the bottom, which might be more appropriate. So here's kind of like either a capacitive or inductive proximity sensor that's telling us if something's in close proximity, giving us that presence detection, right? And we could probably do hours just talking about the different types of sensors out here, but here's kind of two categorical types of input devices. Analog signals, okay, these are the time-varying signals, and fortunately these kind of fall into a couple of buckets of common ranges of industrial accepted ranges. So we're talking typically about different types of sensors that are able to signal what's happening in terms of common signals of 0 to 10 volts, or plus or minus 10 volts for that type of signal, right? So this is where you might have a pressure sensor, and the pressure might range from 0 to some pressure value that the actual output is 0 to 10 volts. This might even be things like speed of a variable speed AC drive that's plus or minus 10 volts. So full speed forward at 60 hertz is plus 10 volts, reverse is minus 10 volts. You might have pressure transducers with 4 to 20 milliamps. You might have specialty temperature sensors that utilize even yet another more specific interface like thermocouples or RTDs for that. Or another one, where you might be using, this 4 to 20 milliamp, which is really preferred for some of these applications. So it's good to understand, what you want to interface, what that signal format is, and how you might want to bring that into this. Now, when we talk about these types of sensors and being able to bring those into a common technology like IP networking and specifically Wi-Fi, you need to understand first how to interface with a sensor, and number two, how we're going to get that raw information like a 0 to 10 volt signal into something that maybe your SCADA system can understand. Whether you're utilizing something like Wonderware or pick any of the dozens of other great packages out there with which to do that. And this means there has to be a common way for us to talk. So today we're utilizing English as our communications protocol. So fortunately you folks understand me because I don't know very many languages and I'm kind of limited to English. So our communication protocol today is English. And that's very similar to some of the industrial communications protocols we'll talk about out there. We talk about protocols, particularly some of you folks that might have been, here in factory automation, industrial automation for a number of years. I think you've seen, some exciting things taking place, and this kind of shows some of the things that have happened of moving from all of these field buses that were really fragmented, and the exciting part is the big push has been to IP technologies running on some form of Ethernet, whether wired or wireless, and we've kind of taken all that fragmented network or fragmented field bus, and the top three are Modbus TCP, Ethernet IP, and Profinet. These do tend to have specific use cases for each of these protocols. Again, Modbus TCP, Ethernet IP, and Profinet. And I'm going to generalize here a little bit. We can't do as much as we'd like to do in these webinars, so I'm going to kind of talk about the most common way to easily do this. And the first mover advantage really went to Modbus, and we're going to talk a little bit about that. Not that that's the only means to be able to do some of this I/O to Wi-Fi, but it's the easiest and most flexible and most understood on that. So some of you might know a little bit about Modbus. For those of you who don't, I want to spend just a few minutes to kind of review a little bit about what it is, what it does, and why it's so good for this type of thing. And I think one of the things that I really like most about it is it's really one of the pure, and maybe some of you folks have heard about this open source software movement or open standards. It was really one of the first open standards in industrial automation where the publisher, and this goes back to Modicon at the time, said, hey, here's how we connect things, here's how we do it, here you can have our protocol and connect whatever you want. There's no program to join, there's no license fee, just go use it. And that was really kind of the heart of the open source movement, and they were light years ahead of everybody else out there to do this. It's not the prettiest, it's not the most sophisticated, it's not the most elaborate means, but it gets the job done. And Modbus is kind of brilliant for that aspect of it, in that if you had to pick something, you can always find a Modbus solution to solve your problem. And I imagine that in your existing systems you're supporting, there's easy ways to do this in. Now, just as a quick review, Modbus utilizes a technology that uses a master-slave or client-server architecture, which really fits well for most SCADA and data monitoring collection applications, which means it utilizes a register-based read-write type of architecture for that. And while it started out with serial ports, it was rapidly adopted for a lot of things. So it's going to show a little bit of its age here, kind of going back to a PLC type communications. But it's amazing how many things you can get to connect up to that. And the standard, through being able, being kind of updated and moved over to support IP technology in both Ethernet and Wi-Fi, is really applicable today for some general purpose applications. Here's a little bit more about that, maybe a little more that you might want to, kind of refer to this after the webinar for a little refresher on it. Lots of great, resources out there to study more about this if you're not familiar with it. But again, it shows the master-slave organization here. In this example, we're using, this simple example for a wired application where the master on this is an HMI screen and a control panel talking to a PLC over here as a means to do that. HMI is the master, PLC is the slave. There's a communication protocol of Modbus. I want to read how many parts have been manufactured in the shift. Tell me what the address of that register is. I want to read that and send some data across. Here's a little bit about how that protocol works with which to do that. It just says that here's how we move information back and forth across those devices. Now, Modbus has some specifics on doing it. Do we want to read on-off status? That would be through a coil as an output or through a contact as an input. I just noticed in the slide those are reversed on that. Or are they register values, which would be things like analog devices? How many parts have I run in this shift? What's the current temperature? What's the current pressure? What's the height in a tank? Those are all register-based analog types of values for those over here. Likewise, what types of things can we do? We can read inputs, we can write outputs, we can read blocks of registers. This is some of the underlying protocol aspects of that for you with how to do that. Once you kind of have that in place, deploying your solution is really simple once you've defined what the device is that you want to connect, what type of physical interface to have. So here's where that device comes into this. Here's all of your on-off status, whether that be proximity sensors, whether that be level sensors, whether that be limit switches. All of those are going to be your on-off status. If you're looking at time varying signals or analog signals, is it a temperature? Is it a pressure? Is it a humidity? Is it a weight that's coming in? Maybe you want to be able to control the speed of a variable speed drive, and that's done through a 0 to 10 volt signal as an output. Here's where those come in. And the critical part of this is being able to drop in a small, inexpensive module that bridges those discrete or analog signals to Wi-Fi. And this is where you'd have this smart device here that's able to communicate with Modbus. And all of these analog devices and discrete devices are addressable via Modbus through your access point, coming back into the rest of your system via Modbus TCP over Wi-Fi. So I think, it can look complex, but when you break this down into the individual pieces of understand what you want to connect, drop in the small module here to get those signals onto Wi-Fi, understanding that Modbus is one of the really easy to deploy technologies for communications back through your wireless access point onto your plant-wide network, bringing this into whatever software you'd like to have with which to do the rest of your applications. So I think hopefully I can convey to you folks joining us today, how easy it is to do this. And if you haven't done this, it's really easy to get a couple of units, take it into your lab and set this up, and really easy to do these types of applications. And they're actually very scalable for some really interesting applications for this type of technology. And I could go on and on in some of the applications we've seen with which to do that. So let's kind of move on here a little bit. I want to make sure we keep us on schedule so we can open up a little bit here shortly to some Q&A session. In terms of the Wi-Fi, I hope we've been able to kind of give you some ideas on how to do that. And I think with the approach we take to this, it's really easy to deploy this technology, thinking about, what it is that you want to accomplish. And this really starts at the very edge of your network on this, much like, bringing serial onto your network. What are your I/O needs? How many inputs? What type of inputs? What type is it that you want to connect? You really have to start with that survey of, what it is you're trying to connect. Likewise for how many outputs do you need? What type of outputs are those, right? Are they discrete on-off? Are they going to be analog signals with something maybe a little smarter that you want to control something with that? Likewise for your communications. Now, just for our purposes today and not having a lot of time to get into lots of detail, what is your communication protocol you'd like to use? We certainly like to endorse open standards that allow you to do best of breed solutions to be able to bring things together very quickly. And I really like Modbus TCP because it's simple. There's lots of compatibility with cross-vendor solutions, and it's easy to implement. So that's certainly one of them. But by no means is it the only solution to use for this. So think about that. If you are in applications where you have to mix and match protocols, understand that it's not a one-size-fits-all application. There are technologies like a industrial Ethernet gateway that's able to convert between things like Profibus and Modbus TCP, or I'm sorry, Profinet on the Ethernet side. There are other things you can explore for that. Also on the communications, it's good to understand, how do you want to interact with those field devices? How often do you have to read those inputs and outputs? What is that process to update those? And this is where it takes a little bit of discussion with what you're going to do on the software side of things. And lastly, are there other communication needs? And we've simplified a lot here today and talked about more of a industrial automation centric view, utilizing MES type software for your manufacturing usage, or SCADA software, or HMI software. But there are other types of things that can be just as valuable for applications where maybe there isn't really a heavy centralized software play on this, and maybe you just want to be able to have, when an input turns on, be able to send an email notification as an alarm condition. There are ways to do that are real simple without having to have a centrally deployed software to do that. Or maybe you will work closely with your IT team. The IT has their own protocols they'd like to use, and maybe it's simple network management protocol, or SNMP. There's a great way to be able to bridge, the I/O in your plant to an IT technology. We find this being used for some applications. Is that required? So again, this is in that process of doing the survey of the stakeholders in your project and what they want to do. It's really good to get an understanding of what they want to communicate, where it has to go, and how they want to do that. Lastly, in those other application needs, and we talked today really about the most simplest type of I/O, just in terms of getting those physical assets into your network and communicating with something simple like Modbus TCP. Sometimes those I/O needs have to have a little bit of intelligence, and I kind of led into that talking about, maybe the I/O device could send an email notification, or maybe it could send an SNMP trap into my IT management software to let the IT guys know that the generator out back of the plant has just gone offline, and maybe the folks need to know that that's happened via the IT system on that, for that. And this is where, if you need to do a little bit of built-in logic processing in the I/O, or maybe you need to do data logging in case there's events, there's periods of time that the networks is not available, or maybe the data collection has to happen so fast you're worried about transporting it across the network. You're in this area called smart I/O, and there are solutions out there to do that that are very easy to deploy, easy to set up, without having to know how to program ladder logic or how to write code in C, that are out there that are great solutions for you. So that's where to think about, are there other needs that might need the smart type of I/O type of solution out there for you now? So a lot to think about, and we just wanted to help you kind of think big and help you think in advance about some of your needs for the applications to consider this last form of connecting these less intelligent assets at the very edge of your network, and kind of round out our whole topic for today with reaching out and utilizing Wi-Fi technology with which to do that. So I think we're close to opening it up for Q&A, and we'll bring Ariana back online with us here. And Kelly, I'm going to pass it over to you, and could you give us a little bit of, let us know what we have for questions that have come in online.
All right, thanks, Paul, and thank you, Ariana, too. That was a great presentation there. We did receive a couple of the questions that we had throughout the presentation, so I know we are almost at the end of our presentation there. We do have a question that was from Leslie. She asked, can I connect both serial and I/O devices to the same Wi-Fi network?
Yeah, thanks, Kelly. Really good question, and kind of crosses over a couple topics we talked about today, but maybe didn't connect the two together. Absolutely, and that's really one of the underlying benefits of utilizing IP type of technology and these open standards like Wi-Fi. So even on the same wireless access point, it's able to have multiple devices, whether one of those devices might be a device server connecting to an intelligent serial asset, or even something as simple as discrete I/O going to some type of production machinery. Both of those can coexist in the network at the same time, and this is the real beauty of this technology, of being able to carry multiple things across that connection at the same time. And I think the good example is kind of like for those of you folks attending today. You're at your desktop utilizing your web browser, and you've got audio coming back if you're listening through your PC. All of these individual protocols are taking that advantage of IP technology, and all of those same technologies can work for you in these industrial applications, mixing and matching all of that, and utilizing that IP technology.
All right, thank you there, Paul.